Hi guys. So in this video, we will be covering few points to remember, and these points will help us solve more numericals. Okay. So whatever numericals we will be seeing in further exercises, problem solving, or whatever we will do in those parts. Now we will be starting with exercise 1.1 soon. So in exercise 1.1, we will be using these points to remember. So basically these are formulas or methods to perform a certain conversion of degree or to perform a certain type of or to tackle a certain type of numerical. Okay, so points to remember. The first point, to convert degree measure into radian measure, multiply degree measure by pi by 180. Okay, so over here we are converting degree measure into radian measure. Okay, now for example, theta is equals to 90 degree has been given to you. I need 90 degrees in terms of radians. What I'll do, I'll multiply it simply by pi by 180. Okay, 90 and 180 get cancelled. 2 is remaining in the denominator. I'll get pi by 2 radian. And that's how I convert 90 degree to pi by 2 radian. Okay, and that's how the conversion takes place. We need to multiply by pi by 180. That's the first point. Coming to the second point, to convert radian measure to degree measure, multiply radian measure by 180 by pi. Again, we will take an example and try to solve according to it. For example, theta is equal to pi by 3 radian is given to you. I need to convert this radian measure into degree measure. What will I do? Pi by 3 into 180 by pi. Pi by 3 into 180 by pi. I'll cancel pi. 3 and 180 will be cancelled. I'll get 60 remaining. So 60 degree is the answer. So over here, pi by 3 radian has been converted to 60 degrees. All right. Yes. So that's how the first 2 points cover the main concept of exercise 1.1. Majority of the sums will include this particular step where you need to convert either degree measure into radian or either radian measure into degree. Now going to the third one, point number 3. We'll go to point number 3 of points to remember. Point number 3, it's about relation between angle and time in a clock, where R is rotation. R is rotation. Okay. So first one, there are 2 hands. We consider 2 hands in a standard clock. We consider the hour hand, and the second hand is the minute hand. Okay. So one rotation is equals to 360 degrees. We agree with that. In case of minute hand, we are focusing on minute hand right now. Okay. So one rotation gives you 60 minutes. That means 60 minutes is representing 360 degrees in case of minute hand. Okay. Now 1 minute will be how many degrees? 1 minute will be, if we cancel 60 and 360, we get 6 degrees remaining over here. So that will be 6 degrees. So 1 minute is equal to 6 degrees of rotation. Okay. So that's the first relation you need to remember. 1 minute is equals to 6 degrees. Now let's talk about the hour hand. Let's talk about the hour hand. Okay. In case of hour hand, one rotation is equals to 360 degrees, of course, and this 360 degrees will represent 12 hours of time. So 12 hours of time is equals to 360 degrees. Now 1 hour will represent how much degree? We'll cancel from both sides, we'll get 30 degrees, right? 1 hour will represent 30 degrees of rotation. Okay. Now the same 1 hour also represents what? 60 minutes. Same 1 hour also represents what? 60 minutes. Yes. So for our end, 60 minutes will be equal to how much? 30 degrees. This is for hour hand. Okay. It's not for the minute hand. It's for the hour hand. Okay. So it's different. So 1 minute of hour hand will be 1 by 2 degrees will be how much? 1 by 2 degrees. Fine. So that is the conversion for two different hands, two different representations of time and angle. Okay. So I hope you have noted this down. In the next lecture, we will be covering a theorem related to radian measurement. Okay. And after that theorem, we will be starting with the exercise 1.1. So thank you so much. Meet you in the next lecture.